Welcome to Unit 4, Day 4. This video will be the proficient version of the lesson. If you are looking for the basic or advanced, please stop and go back to the main page. Today's lesson is on multiplying polynomials. And multiplying polynomials, the simplest version is when you're dealing with monomials. So here's my first example, and you might in your head say, wait, that looks like an exponents problem. And yeah, you're right. Actually, multiplying with exponents is really just part of multiplying polynomials. In this case, I want to just take a moment to clarify one of the most common mistakes that I see, which is how to negotiate an exponent that's outside parentheses. I'll show you two methods for this first problem. So basically what we have is we have one monomial right here, and we're multiplying it times another one that's raised to a power of 2. The intuitive way to multiply these is to remember that a squared means that we're taking this term and multiplying it 2 times. So I could rewrite this problem thinking about it this way. 2xy cubed times 3x to the 5th y times 3x to the 5th y again. And now, because we're multiplying, we don't really need like terms to multiply. We just multiply each piece by its corresponding element. So I would start with the coefficients. 2 times 3 is 6. Times 3 is 18. And x times x, when you multiply variables, you add their exponents. So that would be x to the 6th times another x to the 5th becomes x to the 11th overall. And when I multiply the y's, I have y cubed times y, that would be y to the 4th, times another y would be y to the 5th. And that becomes your final answer. Now, if that seems like a lot of work, there is another way that you can do this. The correct way to deal with an exponent outside parentheses, and that's really different than multiplying 2 terms. This is raising to a power. You can distribute this 2 in. And the only thing that you need to remember is you're distributing an exponent, not a coefficient. So we're not just going to multiply 2 times 3. We're actually going to raise it to a power. I'll keep the first term like it is for the moment, and just deal with that second term that has the exponent. Make sure that you don't multiply the exponent to the first because it's not in parentheses with that exponent. So when I distribute the 2, this becomes 3 squared. And then the next piece, x to the 5th squared, is going to become x to the 10th. Because in this case, you are multiplying exponents, not adding like this. Multiplying exponents when you distribute them in, and we get y squared. Now here, I'm multiplying terms, which is the normal process of adding exponents. And 3 squared is 9, and 9 times 2 is 18. And x times x to the 10th is x to the 11th. And y cubed times y squared is y to the 5th. And you'll see that we get the same answer. This is sort of a shortcut, but it requires that you're really solid on the difference between an exponent outside parentheses and just multiplying 2 terms that both have exponents. Based on what I've just said, please complete the following 2 sentences, and then you have 2 practice problems to complete. When you're ready to see the answers to these 2 practice problems, press play again. Here are the first 2 answers. There's number 1 and number 2. In the second example, we're no longer dealing with monomials, and this creates a huge difference in the way that we're going to do our work. Instead of just multiplying a term where you can easily enough multiply all the coefficients, or where you can just distribute in an exponent, we now have a binomial with 2 terms and an exponent outside. Do not distribute this exponent. You cannot distribute exponents when you have 2 different terms or when you have addition or subtraction. What you have to do is understand that kind of long method, which is this squared symbol means I'm taking a binomial and I'm multiplying it times itself. In this case, that means that I'm multiplying 3x to the 4th minus 5 times 3x to the 4th minus 5. And once you have it written this way, you probably know what to do because this is just a FOIL problem. I'm going to multiply 4 different times. Sometimes we draw these arrows to make sure we don't miss any of them. 3x to the fourth times 3x to the fourth is 9x to the eighth. I'm adding exponents because I'm multiplying the whole terms. 3x to the fourth times negative 5 is negative 15x to the fourth. Negative 5 times 3x to the fourth is again negative 15x to the fourth. And negative 5 times negative 5 is positive 25. For some reason, a lot of people will get this last sign wrong. I'm not sure why, but just watch out for that. The last step, of course, is to add your like terms. When you're adding, you don't change your exponents, so keep these three levels kind of separate. Multiplying exponents when you do this, adding exponents when you multiply the terms, and keeping the exponents when you just add terms. The final answer is 9x to the eighth minus 30x to the fourth plus 25. Quick tip for this type of problem is just your reminder that when you have an exponent of 2 on a binomial, you do have to FOIL. And 2 practice problems for you to complete below. When you're ready to see the answers, just press play again. Here are the answers to the second 2 practice problems. There's number 3 and number 4. The last example, instead of 2 binomials, we're now going to deal with a binomial and a trinomial. And this is really just an extended version of FOIL. It's pretty intuitive, but you have to make sure that you don't miss any of the terms. If I'm multiplying 2 pieces by 3 pieces, it actually means that there are 6 different multiplication problems. Let's see if we can find them all. So I'll start with the first term, which is 2x, and I'm going to multiply it times each of the terms in the second polynomial, which means 2x times x squared is 2x cubed, 2x times 3x is 6x squared, and 2x times negative 4 is negative 8x. That's the first half of the problem. The second half is when I take the negative 1 and multiply it again to all 3 pieces in the second polynomial. Negative 1 times x squared is negative x squared, negative 1 times 3x is negative 3x, and negative 1 times negative 4 is positive 4. Now all I need to do is add like terms. 2x cubed is on its own. 6x squared minus x squared is 5x squared. And negative 8x minus 3x is negative 11x. And plus 4 is at the back. That's your final answer. Okay. Based on this, and maybe comparing this to the last example, you can probably generalize a pretty interesting rule here. See if you can fill in the blank. And then later in class, you may want to connect that to another pattern that we will see. Your final practice problems are as follows. Press play again when you're ready to see the answers. Answers for 5 and 6. Here you go. That's 5. And this is 6.